What if you could build RAG without managing chunking, embeddings, or vector databases? That's exactly what Gemini File Search does. But to understand why that matters, we need to see how RAG actually works. Gemini is Google's multimodal AI system, and RAG, Retrieval Augmented Generation, is what you use when your app needs to answer questions using your data, not just what the model was trained on. Let's start with traditional RAG. Chunking. When you upload documents, they're broken into smaller pieces called chunks, because large documents can't be processed efficiently all at once. Embeddings. Each chunk is converted into an embedding, a numerical representation of meaning. This allows the system to understand semantic similarity, not just keywords. Vector database. These embeddings are stored in a vector database, optimized for similarity search instead of exact matches. Semantic search. When a user asks a question, that query is also turned into an embedding. The system then finds the most meaningfully similar chunks. Retrieval plus prompt injection. The most relevant chunks are selected and inserted into the prompt sent to the model. Generation. And finally, the model generates an answer grounded in those retrieved chunks. This entire pipeline, from chunking to generation, is what we call RAG. Now let's compare that with Gemini File Search. With Gemini File Search, the pipeline doesn't go away, it becomes managed. Chunking, embeddings, storage, and retrieval still exist, but they happen behind the scenes. You don't need to build chunking pipelines, embedding systems, vector databases, vector storage, vector retrieval, retrieval logic. But you still get some control. For example, configuring chunk size and overlap. RAG isn't removed, it's abstracted. Let's zoom in to retrieval, because this is where the biggest difference shows up. Traditional RAG. You embed the query, search the vector database, manually inject results into the prompt. Gemini File Search. Gemini handles retrieval internally. Traditional RAG exposes retrieval, Gemini compresses it into a single step. Relevant chunks are automatically selected, context is injected automatically, and responses include built-in citations. Metadata. Metadata is structured information attached to documents, like category, region, or document type. Why it matters. Instead of searching everything, you filter first, then run semantic search on a smaller, more relevant set. Custom metadata. You can define fields like finance, US region, travel policies. Example. So instead of searching all documents, you search a filtered subset and then find the best matches. Metadata turns unstructured files into structured knowledge. Gemini File Search also provides built-in citations. Each response can reference the exact chunks it used. That improves trust and reduces hallucinations. In traditional RAG, citations are manual. Here, they're automatic. With traditional RAG, you control everything. With Gemini File Search, most of it is managed. You're trading control for speed and simplicity. You're trading flexibility for velocity. There is no time to live for embeddings and files. They persist until manually deleted or when the model is deprecated. Managing your usage and billing with Gemini File Search is simple but important. Key billing insights. You pay for embeddings when you index files at 15 cents per 1 million tokens. Storage is free, and query embeddings are free as well. You only pay for retrieved document tokens during inference. Rate limits. The File Search API has certain rate limits to ensure service stability. Max file size per document, 100 megabytes. Total file search store size, based on your tier. Free, 1 gigabyte. Tier 1, 10 gigabytes. Tier 2, 100 gigabytes. Tier 3, 1 terabyte. Recommendation. limit each file search store to under 20 gigabytes to optimize retrieval latencies. This is what it looks like in code. You start by creating a file search store. This is basically a managed container where your documents live, so Gemini can retrieve from them later. One API call creates retrieval system. Upload file. When you upload a file into the store, Gemini immediately processes it. Behind the scenes, it automatically breaks the document into chunks, converts each chunk into embeddings, indexes everything for semantic search, so you don't build any of that manually. This is the first major abstraction. Your document becomes searchable instantly. When you query the model, you don't manually retrieve anything. You just attach the file search tool to the request, and Gemini handles the entire retrieval pipeline internally. No vector DB code, no retrieval logic, no prompt stuffing. So instead of building a RAG pipeline step by step, you simply enable a tool and retrieval just happens. And the output isn't just an answer. Gemini also returns citations, showing exactly which parts of your documents were used. This makes the system production ready because every answer is traceable back to source content. What you've seen is the difference between building RAG and using managed RAG. Traditional RAG gives you full control. Gemini File Search removes the complexity by managing the pipeline. If you want speed, use managed RAG. If you need control, build it yourself. Next, API will go one step further. Stay tuned.